I'm Bob Knadler with Hanson. I'm actually subbing for one of the presenters this morning who could not make it, but two of the others, Drew Daly and Jonathan Noordzy, are here with Hanson, and also we have a representative, Tom Goodwin, with the Orange County Public School System. So a little bit to start out with respect to the presentation, you see the title, Evolution and Benefits of a District-Wide Commissioning Program. So to give you a little bit of a history here, what we're talking about is the Orange County Public School System. And for those that are not from Florida and have flown in to visit this area, just to give you an idea of the growth of Orange County, which is essentially Orlando, it's been incredible over the last roughly 10 to 15 years. So the school system has embarked on an incredible growth program, adding a number of schools, renovating schools, having additions to existing schools. And to give you an idea, since about 2002, 2003, they have the exact numbers. They've raised through bond programs about $2.8 billion, of which they have an ongoing fund of about $1.8 billion in that range. They've added 50 schools over roughly the last 14 to 15 years. And within that, this year's budget for capital projects is around 600 to 700 million. So you can see it's been a very aggressive program, a lot of construction. And before embarking on that, they had previously not done any commissioning. And they understood that if they're going to be a fiduciary responsibility to the taxpayers, that they've got to make sure with an ambitious growth plan and that level of construction, that level of growth, and with that speed and rapidity, that they needed to have some sort of a risk assessment, quality control process. So they embarked on commissioning, building systems commissioning. And when it first started out, it was really more targeted strictly in a construction acceptance phase. That's really where it was. But over several years, they understood that as we identified a number of issues, that there could really be a lot of benefits brought if we were engaged earlier during the design phase. And so they did that. And then over a couple more years, when they started to see some of the ongoing issues and some of their standards could be better served if we got involved and helped to edit and refine some of their design standards, some of their construction standards with respect to the contractors, that would help as well. So one of the things that they'll talk about today is, again, how that program evolved over a number of years, and then the benefits. At the end, they'll share the benefits with you that Orange County Public Schools has seen over what's really been about a 15 to 16 year odyssey so far, and continues on, as I said, because again, the rapid growth in population in Orange County here. So with that, I'm going to turn it over to Drew.
Okay, testing. Good morning, everyone. Again, Phil sends his regards. He was called away on medical emergency this morning. He wouldn't be able to make it. So what we have here is the OCPS commissioning program, their advertised scope of services as listed above. You might see that everywhere. We put down some specific notes here that we don't see everywhere. Oops. And one of those happens to be that we helped develop the template for the CX services, and that OCPS has a much higher rate of sampling than our standard jobs that we see. Often we see 10%, 15%, 20%, and in much of their equipment we test 100%. We have also an expectation that Hanson will follow up through the closure of every issue instead of leaving some lingering issues and having the contractors give you their word that they'll follow up on it. We actually close out every one. Another one that is I don't see all the time is that OCPS's upper management actually appears to walk through every school prior to occupancy. That's a pretty big deal. I'm going to turn it over to year one.
Yeah. As Drew and Bob said, the first year of the commissioning for Orange County Schools was primarily construction phase only, so no drawing reviews were performed, no submittal reviews were performed, just on-site functional performance testing. And the first year was just three schools right here, and as you can see, the issues were kind of surprising. They ranged from 44 to 129. One of these schools, they had a real hard time with test and balance validation. And I'm not here to slam test and balance contractors, but at Well, I think what happened is a lot of contractors were not aware that commissioning was coming on board, and somebody's going to actually check their work. And with the test and balance validation process, one of these schools actually failed, and the contractor had to rebalance the whole school. As we said, the issues varied from 44 to 129. They found quite a few problems. The space temperatures in all the classrooms were very inconsistent. Test and balance reports could not be duplicated. They did a very good job of validating the process. They actually had the test and balance technician try to replicate his numbers within 5 or 10%. These schools had some chiller control issues. They would not stay online. They had some bad control problems. They kept on shutting down. So these first 3 schools had a whole bunch of problems, which found through commissioning. Secondary chill water pumps had a lot of problems. The pressures are way too high. They're obviously having problems with the chillers, and various AHU control issues. And after first one, the process was improved by Hanson conducting seminars for our OCPS project managers. They were a bit leery of the whole process, so they actually did a couple of seminars in-house to explain the benefits of commissioning, to get them on board, to make them feel better with the whole process so they could perform their job a little bit better. And the other thing they tried to do is to get, obviously, commissioning started a lot earlier, like in the design phase, so we could actually review the drawings and do the proper commissioning process. And they also adopted a red light, green light spreadsheet, status report for OCPS management, so that a project manager can look at the spreadsheet and tell right away exactly what's happening, if he had problems, if he didn't have problems, if there's issues to be resolved, and all that kind of stuff. That was really good.
Okay, in year 2, OCPS granted our request and brought us in earlier into the commissioning process. We were able to come in at the end of the design phase and review the final design documents. OCPS gave us 8 schools, 6 elementary schools, 2 high schools. And as you can see by the numbers, we're starting to catch the issues earlier. You're seeing we're catching a number of issues on the design drawings before they get into construction. And I thought back to one of the things in my original commissioning certification training back in 2006. I heard Chuck Dorgan say many, many times, commissioning is a quality process. So as such, the rules of statistical science apply. So any quality process, the earlier you can get in and get it started, the more fruitful and the more cost effective it is. So you can see here, we're catching a lot of issues earlier. The number of issues ran the gamut from around 70 issues to we had some problem children, a couple over 200, one nearly 300. So we kind of had our work cut out for us when we got into it. Some of the things we found in year 2, this was the year of pipe flushing fiascos. On one project, we were told that the pipe flushing process had been done adequately, and we kind of left it to the means and methods of the contractor. And it was only until we got several months in that the complaints started that we realized what had happened. Classrooms started to get hot complaints because the air handling units couldn't maintain their supply air temperature set points because they were getting starved for chilled water because the system, it turns out, was not properly flushed. What you see on top is a basket from a 4-inch pipe strainer, so plugged up with construction dirt and debris that the only open passage for is about the size of your finger. So it was the restriction of flow was substantial. Down the bottom is a picture from inside the heat exchanger, plate frame heat exchanger. We see laying down there is welding slag. That's in some cases, the smaller pieces of slag actually fell down into the flow channels between the plates. And ultimately what had to happen is they had to go in and take this plate frame heat exchanger apart to get all the debris out of it, pressure wash the plates, put it all back together. And that was a very costly proposition. Incomplete test and balance. Again, the vast majority of test and balance guys I worked with, honest, hardworking, knowledgeable, take great pride in their craft. But unfortunately, this was an outlier. We got complaints of pressurization problems in the classrooms. Namely, the classrooms close to the air handling unit were very negative pressure, hard to open the door. The ones further away were very positive. They were blowing the door open. Turned out that the return air ductwork was never balanced or never balanced properly. So that was, we made that discovery, and they had to go back and rebalance the return ductwork. We had issues with the BAS, mainly coming from sequences of operation that were either incomplete or the logic was faulty. They just didn't work. One project had relief fans running backwards. This next one is worth taking a couple minutes to talk about because this plagued us for several years. We all know the logic behind this. Low VAV minimum settings save energy, no doubt about it. You plug it into any energy model, and that's what you'll see. It saves energy. The problem is if you take this idea too far, it creates problems that far outweigh the energy savings benefits. Namely, just to give you an extreme example, one of the VAVs we had was connected to 3 diffusers and had a minimum scheduled setting of 25 CFM. Now, if you want to see a test and balance guy laugh, ask him to balance a diffuser at 8 CFM. It's just not feasible, not practical. So, and what happens is also a VAV box down that close to the to being closed, it doesn't control very well. A lot of times it would just go closed and you have no airflow at all. So even though it was 74 degrees in the room, the occupants would feel stuffy, they feel uncomfortable, they complain, and the guys from OCPS maintenance have to get in their van and go out to the site and figure out what's wrong. And the other bad effect of this, of the low VAV minimum settings, is poor air distribution in the classrooms in particular. When the airflow is low on a diffuser, instead of the air coming out of the diffuser and hugging the ceiling, dispersing into the room evenly, it just kind of dumps into the room. So the poor student that's sitting underneath the diffuser gets 55-degree air dumping on their head all day long. And the student that's a little away from the diffuser gets hardly any airflow at all, and they feel stuffy all day long. So, that's just not a good situation. So we lobbied and pleaded for them to increase their minimum settings. One project had classroom air handling AC unit controls. They just were not coordinated with the BAS. It was a procurement error. The units were supposed to be ordered with factory controls. They weren't. The BAS contractor thought they were interfacing with the factory controller inside the unit, but it wasn't there. So the BAS contractor ended up having to go back and put their controls in, again, at additional cost to the owner. Year 2, several ways we improved our process. We continue to push hard to have the commissioning begin earlier. We had a pipe flushing meetings as a lesson learned from what that debacle we had. We'd sit down with the contractor at every commissioning kickoff. We'd have a separate meeting, and we go over the entire pipe flushing procedure. We'd ask, where are you getting the water? How are you doing your initial flush? Are you bypassing every coil, every heat exchanger, every chiller evaporator barrel for the initial flush to keep the crap from getting into the coils in the first place?
Are they doing that now? Are they actually doing bypasses?
Oh, yes, they do. And that's one of the things we check when we go to the field we actually visit the field before the flush, and we make sure everything's bypassed. And if it's not, we make an issue of it because we saw, how bad things can go when they don't do that.
Haven't they adopted a standard for that now?
Yes, what happened is actually OCPS ended up upgrading their design guidelines with a very robust and detailed pipe flushing procedure. And now that's a part of every commissioning specification, every engineering specification.
Do you let them use this new construction? Do you let them use the new pumps to do the flushing, or do they have to provide temporary pumps?
It depends. If it's a chiller with integral pumps, we can't allow them to do that because the pumps go right through the plate frame evaporator. So if it's external pumps, we let them do it under certain controlled conditions. If the pumps are internal to the chiller, they got to bring their own temporary pump rig. Controls coordination meetings, again, it really helped. We found to get together with all the stakeholders and talk through all the sequences of operation, make sure they make sense, make sure they're complete, and to also make sure that there's no gaps in the areas of responsibility. A lot of times we get to the very end, and it happens a lot with line voltage controls. The electrician says it's control wiring, it's not mine, and the BAS contractor says, well, it's 120 volts, it's not mine, and it's a matter of just having the construction manager buy out the contracts in such a way that gets covered, and that's one of the things you can get out of the way with an early meeting. We had periodic update meetings with OCPS, and these were interactive meetings. One, we would tell them how their project is doing and where they had problem spots which needed more urgent attention. And we also got a chance to ask them, what can we be doing better? And we got a lot of valuable feedback from OCPS on how we could, streamline our process to serve them better and to keep them better informed. The graphic dashboard is just one of the tools we use to do that. Gives them at a glance, how many issues they had, where they came from, what the priority of them was, so they can look at a glance and see, how their project's doing. Year 3, again, we were included at the end of the design phase, and we were able to come in and review the design drawings and specs. And as you can see, it's an encouraging trend. We're catching more issues when we're catching them earlier. So you see more design issues being caught earlier, and you see less construction issues resulting from it. So that's actually shows the benefits of beginning the process earlier. You can see the number of total issues has also gone down. We instead of having 200 or 300 issues, the worst school we had 108 issues, and that was Lake Whitney is a campus with 6 buildings, so that's really not out of line. Where you see the asterisks, they are 2 schools, Clay Springs and Lovell, are twin sisters with the same mechanical design, so we did one design review for both. Same with Independence and Eagle Creek, twin sisters, same design, one design review. Some of the things we found in year 3, again, the low minimum VAV settings continued to plague us. VAV diffusers, I wanted to spend a couple minutes talking about that because it's interesting. A VAV diffuser in the right setting, the right application can be very useful. Like for instance, if you have a kitchen with a low pressure, constant volume system, and you have a kitchen manager and you want to give them, with an office in the middle of that kitchen, you want to give them some climate control, a thermodiffuser or a VAV diffuser works great in that application. Where it gets tricky is when you have, try to use them downstream of a VAV box. And that's where because VAV diffusers have a very narrow static pressure operating range, it's very easy for the VAV box to either overwhelm it, push too much air through it, or starve it. So the way the manufacturer recommends is to put a static pressure sensor in the duct in between to maintain a steady static pressure. Unfortunately, that's not the way it was done. It was done with the design called for temperature sensor in the return duct to control the VAV. So that created problems with admin office getting overcooled, undercooled. And so we kind of brought that to the attention of OCPS, and they actually took that at heart and changed some of their design standards.
John? Yes.
That's correct, in the admin areas. And those are the people you don't want to take off in a school, That's a good question. We asked the same question. Why would you do that? It's just, it can be done, but it has to be done a very specific way, and that's not the way it was done.
What magnified it is you have one VAV box serving multiple offices, and all of them had VAV diffusers on it. So it really created quite an issue. And the return air sensor that controlled the VAV box was sometimes installed correctly and sometimes not. They put it in a return air. They just found a return air spot and threw it up there. And it may be controlling the right VAV box or not. It created quite a problem.
Usually more controls don't solve the problem.
That's exactly right.
That's correct. Well, properly applied, it's good, but wrongfully applied, not so good. That's right. So heater issues, it's kind of interesting. Most of the issues we have with heaters doesn't have that much to do with the function of the heater itself. A lot of heater issues we have is because the airflow isn't correct. This is an example of if you have too little airflow, like you see on this graphic, the heating CFM, the flow set point is 0. So even though the BAS is commanding the heater on, that heater is never going to come on because the safety switch isn't going to make. You got no airflow. So no heater output. And also on the other end of the spectrum, if the airflow is too high in the heating mode, then you can't make the air temperature rise that's on the schedule. We look for, 55 degrees in, 85 degrees out. But if you got way more airflow than you're supposed to, you're not going to get that kind of temperature rise. And sometimes we trace that back to the flow factor being wrong on the VAV box. So the BAS is showing 650 CFM, and you really got 900 coming out of the diffusers. And that's just a simple adjustment we make. But first, we have to find the problem before we can correct it. Couple of projects, the electrical subcontractors went out of business in the middle of the project, and we were able to come in and help OCPS assess the current state of the electrical installation and give them an idea of what was left to be done to complete it. So we're able to kind of jump in an emergency and help them out. Year 3, the way we improved our process is we adopted a cloud-based commissioning web application. Now, CX Alloy isn't the only game in town. There's other systems out there, but we looked at several of them, and we settled on CX Alloy, and we don't regret that choice. It actually has worked very well for us. But CX Alloy just rolls off your tongue better than cloud-based commissioning web application. So I'm going to use it kind of as a generic term. We conducted CX Alloy training sessions for the project managers because we were putting this powerful tool in their hand to collaborate and to see the status of their project. We want them to be able to use it. It turns out that it's a pretty user-friendly, intuitive program. It doesn't take that long to get a basic working knowledge how to navigate the screens, and it's very powerful in many ways. It allows us to do checklisting better, which makes the contractors happy. They don't have to walk around with a 3-ring binder with 4 inches of thick paper in it. They can walk around with their phone or the tablet and fill out the checklists. We provide lessons learned for OCPS to share. Normally, we do that in the final report. We talk about issues that happen repeatedly from project to project to project that are indication of a deeper systemic problem that needs to be addressed.
Thanks, Jonathan. So moving into year 4, we got 8 more schools we go to, and right off the bat, if you're paying attention, you can notice the number of issues kind of increasing and getting a lot higher. And there's a couple of reasons behind that. Number one is the familiarity with the design, the schools, us being out there on the same type of job, knowing what the owner wants. We have a more keener eye for looking and finding issues. That's an upside. One of the downsides is that the contractors now knew that we were coming out, and sometimes they would rely on us to do their punch list for them. So they would call us out a little bit early. I heard a lot of yeahs going on. Yeah. We've all seen it. We've all been there. It plagues the industry, but they call us out when they're not ready, and there's so multiple downsides of that, because not only can't we complete our job, we're keeping the contractors from finishing because they're playing with us, trying to commission their stuff that truly isn't ready. And they're not allowed to finish because they've got to walk around with me and find broken stuff and hit their list. Another one of the issues that we found was some of the manufacturers on some newer equipment, it came shipped with the wrong programming software. And we had some independent classroom units that came to the job site, and they were programmed for a DX system. And of course, we had a chilled water system on the plant. And instead of the manufacturer coming right out and helping us, they didn't send anybody out. They just thought they could do it all over the phone. And that just languished and took us really about a couple of months to get to the final situation where they gave us a flash so we could reflash. We had the contractor reflash every one of the units with the new program itself or set up. Another thing that we found on one of these in year 4, I'll go through this list here kind of quickly, but incomplete BS program, as I did mention a moment ago, a lot of times it wasn't complete. Either the sequences weren't installed or they weren't installed properly, which clearly leads to the fact that they didn't do a pretest before the commissioning guys came out. We had tab incomplete, and the same thing we talked about. You heard Jonathan talk about it a moment ago. We had condensation problems in some kitchens, and that really relied on little or no reheat for dehumidification mode. So the kitchens were dripping, basically had condensation everywhere, so they called an issue out, and the air handler was getting stuck in dehum mode. It couldn't overcome the humidity, so it just stayed overcooling the space, dropping the temperature as low as it could possibly do to wring out the water, but if you can't reheat it, it's not going to work. So it just exacerbated the problem. The classroom AC controls I just mentioned a moment ago, we found some chill water piping reversed, supply piped into the return side. The low VAV minimum settings, Jonathan went in depth about that, so I won't hit that one again. The outdoor air intake duct not sized for partial load conditions, and this one plagued us at quite a few schools. So I've got a picture over here on the right. This is a 10 by 8 outside air duct, which is plenty of space when the fan's at 100%. So then you put a damper inside there to take away a little bit more of that space in the outside air duct, and then when we go into static pressure reset, we take the supply fan and make it go slower. So obviously, if you have a 62 by 26 return duct, the air wants to go through that duct instead. So we drop the return air dampers. All you guys know controls are going, well, just close the damper and return air. Well, when you start closing it down below 10%, all of a sudden you start tripping out on low static pressure. So we had to go back and coordinate with the engineers and say, hey, guys, can you make the ductwork just a little bit bigger? And after a couple of iterations of this issue going on, they've all agreed to do that. We had some issues with bipolar ionization. It was fairly new. Contractors weren't familiar with it. Controls guys weren't familiar with it. So there was some installation questions and some controls questions on how they would hook up to get the alarming coming back. Sensors were put in the wrong spot. One of the things we did to help with that was we actually got the manufacturers who were more than happy to come out in the field and coordinate with everybody. We conducted CXLA training not just for OCPS, but for anybody that was going to touch the program. That's the subcontractors, contractors, the employee that you're going to have enter all your equipment, on the checklist. So if the supervisor doesn't want to do it, anybody that was going to use it, because it's such a great tool that the more people we have using it, the more seamless the project goes. We conducted a lessons learned workshop for OCPS and the engineers of record. I'll get into more of that in just a moment. But one of the things we did at that was discuss how the different designs from the engineers could be made more streamlined to be more consistent for the maintenance personnel on the far end. This is a brief, this is actually the lessons learned workshop that we performed. And you can see there's a whole bunch of things that we had in here on our PowerPoint that we did then. And the biggest thing we did was openly discuss between the different engineers and entities issues that we've had come up. We put it all on the table and we found a resolution to that. What do we think that we want to do with this particular issue? And then we take that issue, whether it be BAS sequencing or duct sizing or whatever, and we would make a determination and then figure out what to do with the path forward. Do we want to incorporate that into the new OCPS standards? Do we want to exclude it altogether? Is it really that big of a deal? Do we just figure it out in the field? Or do we want to leave it as it's currently being done, such as the contractor and the commissioning guy figured out in the field? Here's a quick list of some the items that we discussed at our workshop. Again, you got the VAV minimum settings right there. That was a big one for us. Classroom temperature gradients. If you have an exterior wall and the temperature is on the interior wall, sometimes you get 3-4 degrees difference between the kids over on a computer by the outside wall and what the temperature thinks is going on in the room. A lot of that comes back to air movement in the room. We had controls interoperability issues, and another thing we did was we always increase, and it's a living document, our controls meetings, because we find more and more things that come up, more questions, so we incorporate that into our meetings to make sure that all the confusion is gone. One of our big things right now is meters. Meters are either going to be MSTP or they're going to be IP. Well, which one is it? Because controls guys can't directly connect to the IP one, so somebody's got a network cable back to the network, put it on the school's network. Who does that? That was the question. 3 months later, the drop still isn't there. It's still not seeable on a control system. Design reviews, I'll hand it back over to Jonathan.
Okay, so this is kind of a summary of a lot of this stuff we talked about already, just to sum it up. And some of the stuff is new, but these are kind of common themes that we came across in our review of the design drawings and specs. Some of the details and diagrams were not that clear, not really clear to the contractor what the design intent was, and that led to some installation errors. So we try to clear up any ambiguity at all that we see in the documents, or any conflicts or any errors on diagrams or things that could be misconstrued. Sometimes the airflow shown on the plans did not maintain the perimeter classrooms, slightly positive pressure, which is very important in Florida, as you know, to keep the humidity out. Low VAV settings. Actually, after years of fighting this, the design practices finally changed, and then we saw the minimum settings on the VAVs start to come up. And when that happened, a lot of the previous problems just went away. Spec sections could be made stronger, particularly the pipe flushing spec became much more robust. It had been just a couple of sentences. Now it's a full page with a very detailed procedure. Drew talked about outdoor air duct sizing. We talked about VAV diffusers and the pitfalls of misapplication of them. Controls issues, again, sequences mainly that just don't work. And what happens is what Bob calls the copy and paste syndrome, right? So if there's an error in the engineering drawings, control sequences, the control contractor will, with good intention, say, well, this is exactly what the engineer wants. That's what we're going to give him. So he copies that and pastes it into his submittal. That submittal gets approved by the engineer, and it gets programmed that way. So what happens is out in the field, we have problems later. So we're trying to head that off. Typical submittal review issues. There's some occasions where exhaust fans were selected with a brake horsepower higher than the motor nameplate amperage. Put the motor. It has a 15% safety factor, but you really shouldn't be running it there for its entire life. Again, the copy and paste carried design issues into the submittals if we don't catch them. energy meters. This became a very important OCPS over the recent years. At the very minimum, OCPS wants to be able to monitor chiller plant energy usage, chiller plant makeup water usage, kitchen energy usage, electrical energy usage, and kitchen water usage. And sometimes the energy meters or the water meters don't get included in the control submittals. And in all fairness to the controls contractors, sometimes it isn't so clearly shown on the design drawings. Sometimes it's shown as a narrative with no points list. Sometimes it shows as a point list with no narrative. So there's some inconsistency, but that's something we pay particular attention to because it's something very important to our client. Coordination of sequences between the BAS and the chiller. Sometimes we get boilerplate sequences that are meant for a chiller with external chill water pumps. But when you have a chiller with integral chill water pumps, the sequences have to be written slightly differently. I mean, train CGAM is a great machine, but you have to be cognizant that some of the sequences have to be different because the BAS does not turn the pumps on and off. The chiller controller turns the pumps on and off, so you just have to talk to it a little bit differently. Typical field issues, incomplete sequences of operation, inaccessible valves and filters. I'm not taking your slide, am I?
Yeah, it's all right. You're doing good. Keep going. This is one of my favorite, what we would call the wall of shame photos, because what you see circled up there is an outside air filter. And what you see in the way as I'm standing on the ground next to two great big air handlers is that there's absolutely no way to get to that thing without some sort of degree in acrobatics. So what we look for, and most of us commissioning people will be looking for, is looking out for the maintenance guys. How's the maintenance guy going to get up there and change that? And clearly, if it's that hard to get to, it's not going to get done. I mean, the guy would have to take his life in his hands to get up there and do that. But I'll go back to the list here. We had faulty or incomplete sequences of operation that we find. That's one of the things we try and work through in the field with the controls contractor while we're there. The unacceptable valves and filters. The filter that I just talked through. We have valves above hard ceilings sometimes. You have a nice access panel to get up through there, and then you realize that it's another 10 feet up above that access panel to the valve. And again, how's a maintenance guy going to get to that? You have to either drop a chain or make some other means of access for it. We had pipe and sensor installation errors. Back to the bipolar ionization one. We had one project where the sensor was put 2/3 of the way down the duct, just like the static sensor, but it was called out that way on the print, and obviously it didn't work that way. We had gauges and local displays mounted where they're difficult or impossible to read. One that comes to mind is an airflow monitoring station for the outside air mounted 20 feet up where the ductwork comes in, and I can see the gauge, but I can't read it. Doesn't do me or the maintenance guy any good to know it's there. We have openings and equipment of piping. So as construction is going on, I've got a couple pictures here that, again, everybody's probably seen something similar to this, where they're using the return section with no filters in it as a storage. Other stuff had been put in here, but it was left open. They've got all kinds of dirt and debris in there, and the filter missing makes it even more open to the coil. This is the unit right next to it, and that's how dirt and debris get in there. So one of the things we always want to look for is make sure that all openings are closed, all equipment is protected. Missing air vents on chill water piping, that's a big one we find very often too. Air bubbles are very destructive. Issues from the contractors. Now this is fairly new to me. In only the past couple of years we found that where the contractors complain they don't have enough budget to help us with our testing. So therefore, they're not going to provide us a controls contractor or another contractor that helps with the testing. Well, when we get called to the site and the equipment's not ready, once again, we're taking that budget from the contractor that's there to help us out. Instead of doing his job and finishing, he's wasting his hours on his commissioning budget, which is me, and it's not very conducive to what I'm doing because we can't finish the job anyway. So we've gone round and round with some contractor issues. And the way we want to do that is ahead of time, because on CX Alloy, all of our functional performance tests are listed right there in the test section. It's not a secret. If you tell them, I tell them, use it like a cheat sheet. Act like it's a fire alarm test or a nurse call. You would never wait until the inspector showed up to go through the test the first time. Do the same thing for me. And sometimes they do. So the tab contractor, again, sometimes unable to duplicate airflow readings from the tab report in the field. Overall, what do? We develop and conduct the CX training sessions. These are going to be pretty much a repeat of what you've already heard. Is it you? Go ahead. You're doing great, brother. I'm going to hand this over to Jonathan.
Okay, overall process improvements. We again, this kind of summary of things we talked about before. commissioning training sessions for OCPS project managers, along with the benefits it provides. A lot of the times, the biggest thing we have to do is just explain what the commissioning process is or it isn't, because there's still some confusion about it that you'd be surprised. We continued our informational review meetings with OCPS, again, tell them how the projects are doing, where additional attention may be necessary, and ask them what can we be doing better. And two of the tools we use to do that is the red light, green light summary projects. Green means everything's good, yellow means there's some problems, red means there's stuff you have to deal with right now or it's going to really go sideways. Our summary dashboard also gives them a way to have a quick look at what at the progress of each project. As Drew talked about, we had a lessons learned session for all the design engineers. The OCPS uses 5 different design engineers, and they all have slightly different ways of doing things like static pressure reset or supplier temperature reset. They all do it a little bit differently. None of them are wrong. They're all correct. They're just different. So what we wanted to find out, we got the OCPS mechanical plan reviewer in the room, and we wanted to know, does OCPS have a particular preference in a preferred way that you want this done? And if you do, we respectfully ask the engineers, could you all do it that one way that the owner prefers? So it was a productive meeting. It was respectful. It was more of a workshop than anybody holding court. We increased our staffing level when OCPS told us there was a lot of work in the pipeline, but we got to be ready to man up to meet the demand. So we went from 2 dedicated commissioning specialists up to 4, with several more waiting in the wings for crunch times. We added experienced people who were very guys with a lot of knowledge, a lot of experience. Again, CX Alloy, the cloud-based commissioning application, was just a quantum leap forward from the old days of paper and passing around, binders full of paper and passing around Word files or Excel files that could be accidentally overwrite each other, and only one person can work on them at the same time. The cloud-based application allows multiple contractors to work the same checklist at the same time without overwriting each other. Allows them to work it even where there's no Wi-Fi. They come back in Wi-Fi, they sync it in because it has an offline application feature. We wanted to be proactive in getting the issues submitted using CX Alloy as a communication and collaboration tool and get them tracked to resolution. So we wanted to make sure that OCPS is always aware and has a way to access in real time 24/7 how many issues they have on their project and where they are, so they know what to focus the contractor's attention on. We try to share occupant complaints with the design engineers to get them resolved, and that's led to several updates in the OCPS design guidelines. And last but not least, the pipe flushing procedures. And also, when we talk about the pipe flushing procedure, we also kind of segue into a discussion about when you start up the cooling system early, like in April, because you have to the finish trades are going on, painting, rubbing the walls, millwork's going on. May and June, have to make sure that you protect the return air ductwork with filters so no dust gets into it. Just common sense stuff. Make sure the building is closed in before you try to cool it, so you're not trying to cool Florida and bringing in a lot of humidity that can cause problems. That's you, Mr. Tom.
As you can see, you had a lot of benefits to the Orange County Public Schools via commissioning, and the issue tracking provided a lot of feedback on how specific contractors were doing in all their projects, so that the project managers could, in future jobs, decide maybe or not to use the same contractors over and over. If you had a contractor constantly having problems and issues, I know it's a public entity, but still you can persuade people not to use the next contractor again. We had, obviously, there's reduction in energy. OCPS is working on some good spreadsheets showing where commissioning has aided in reducing energy and comfort in all the schools that are being commissioned on the capital improvement, which are the new schools. Increased occupant comfort. When the first year, we had a lot of school teachers being uncomfortable. The different classrooms were different temperatures. Now, if you walk into the new schools, wherever you walk in school, it's pretty much a constant temperature and humidity situation. And they also gave us an ability to identify and follow issues to resolution prior to warranty period expiration. There's one thing on this that we just did, that all their issues are tracked via CX Alloy, and our project managers looked at it, and sometimes the issues got to the CMs and down to the subcontractors, and sometimes they didn't. And sometimes when you had a 6-month warranty meeting to go over how the school's doing, if you had any issues, some of these issues were still showing up, and this has happened the past 3 or 4 years. Just recently, we talked to OCPS, the upper management, and we got the commissioning folks to work with the PMs, and the PMs have to put those issues into the CM's major punch list. So now it's tied to money. So we're hoping after this year, at 6-month warranty walkthrough and 11-month, there's going to be no issues left. This has been a recurring problem for the first 4 years, and I think we came up with a solution. You put money to it, I think it's going to take care of it. And that just happened in this past few weeks. And some of the steps OCPS has taken to improve the process, we obviously placed increase on commissioning throughout all new projects. We've had all the commissioning performed prior to the end of completion of the design. We modified design guidelines to not proper pipe flushing. We put temperature and humidity limits on supply air reset, humidity resets to make it more comfortable in the buildings. We raised the minimum air flows as they were talking about the thermal diffusers. Again, Hanson doesn't know about this, but we just recently finally got the thermal diffusers out of the design guidelines. I've been fighting for that for 4 years. I got shut down last year. There's upper management problems, political stuff. So we finally got rid of them. So hopefully that's going to go away. We're going to put a VAV box in each of the admin's offices rather than having just several VAVs. So we finally got rid of that. We were also requiring contractor support throughout the CX process. When it first started 4 years ago, contractors were a little bit leery. They didn't think it was going to benefit them, but they realized after the commissioning that it aids them in getting the job done on time and with fewer complaints at completion. And as a result of this, OCPS has implemented a form of retro commissioning. The capital improvement side of the house is going through a lot of the schools right now and doing retro commissioning on existing projects, not only to find out the age of the equipment, if it's going to last longer, if it needs replacing or whatever, and also to bring up less tenant complaints and energy consumption. Who's that?
Let's skip to these. This was analysis of the elementary schools that we had found. And
You didn't know about
we just listed it off. Bill listed all these schools and the number of issues we found just as a tracking tool to find out for ourselves how much we're improving, how much things are getting better. It's there's a lot of variables. And speaking of variables, right here, we had a total number of CMs was 14. We had a total number of BS subcontractors being 4. Mechanical subcontractors was 8. Tab subcontractors, we actually had 10 different tab companies helping us out throughout the course of OCPS commissioning. So all in all, we had 36 different companies. In addition to that, we had different PMs from OCPS assigned. We had 25 different PMs assigned to us. And once again, when it comes down to Hanson, we had 4 people. So we tried to remain more streamlined, keep our head in the game, be more aware of every project that's going on, and not get confused with other things that are going on. So this was the slide we just got recently, and this was showing their kilowatt per square foot, their target, and what we've done as far as, if you can see the numbers here dwindling with my pointer, the numbers here dwindling and going down year 1, year 2, year 3, and year 4. We have beat their sustainability target every year that we've done commissioning on all these buildings. So that right there is a great slide to show that it's definitely paying for itself. How can we improve this type of program going forward? Well, you can formalize a retro commissioning program, as Tom talked briefly about. I have yet to go or hear of any retro commissioning job that has not benefited the owner of that facility. And that's in 16 years worth of commissioning. So we developed a district-wide ongoing recommissioning program to check out buildings that have been commissioning. Things change, things move, things break. It's always good to go and look at them again. Develop a comprehensive measurement and verification program. And if you can't measure it, how can you improve it? develop a district-wide energy roadmap, implement a facility condition assessment. That's a big one right there too. That helps out the maintenance guys tremendously. Implement a district-wide monitoring-based CX program. Again, if you're not looking at something and you can't see that it's changed, slipped, slid, not meeting temperature, then how do we know to fix it? And lastly, to implement a smart schools program. There's a lot of talk about smart buildings, smart schools be part of that. So to wrap it up here, a district-wide commissioning program requires education of the customer and all parties involved, not just the owner, not just the contractors, but everybody being on the same page, working for the same end goal. It works best when the number of variables is reduced. We just talked about those 10 tab guys and 14 CMs. When you work with the same persons over and over again, they know what's expected. They know how to do their job. They know it's going to get checked. It's going to get commissioning tested at the end. They're going to do a better job. It obviously saves energy and money. Reducing callback is huge, especially for the maintenance guys. And this is a good first step for your school districts. Any questions? Sir.
So you guys work directly for Orange County, or like when projects are bid, you bid to the contractor?
We work directly for OCPS. Again,
With apologies for missing the first couple of minutes, could you go over the
that's
pipe?
where all the good stuff was.
Could you go over the pipe flushing, the procedures, and what you did to improve it?
Yeah, I can defer to Jonathan on that because he was the first one that actually brought that out. When he started, we basically just relied on the contractors, and the contractors talked a good game. One of the I'll say best horrible things was a contractor saying, "I've been flushing through the coils for 25 years. I don't have to bypass them." And so my joke was, "And you've been changing out coils for 24 years?" So.
Okay, so to delve into it in a little bit deeper detail, and this was kind of a learning experience because we did some research to find out what a really robust and thorough pipe flushing process entails. So, the first and foremost, anything that with small orifices that can get clogged up with dirt and debris have to be bypassed. So coils, chiller evaporator barrels, or plate frame heat exchangers, you got to bypass them. You also want to bypass control valves because the grid will get in there and foul the seat up, and also autoflow valves because the grid gets into the cartridge, the factory calibrated cartridge, and then you have a restriction there. So those are some of the pitfalls we learned about, and we kind of avoided, and we warned them about ahead of time. We want to know, our meeting starts off with where are you getting your water? You're not getting it from not that they're taking it from a swamp, but we want clean municipal water going into the system, or from clean water from a water tanker to go in. And we asked them, where are you doing a feed and bleed? Where you feed clean water in from one end and you bleed out the dirty water from the other end. How are you doing that? What durations are you using? How long are you flushing the piping? Because you could have different required durations depending on how big the system is. Some of our schools are just a single building. Some of them are high schools with 8 or 10 buildings on them, and it's a very extensive underground piping, chill water piping system. So that takes longer to really do if you want to do it thoroughly. And I think that's one of the mistakes they made in the photos shown before, is they just didn't flush it long enough. They didn't bypass the sensitive equipment, and 2, they just didn't flush it long enough on the initial flush. And once that stuff got into the underground mains, all that dirt and debris got into the underground mains, it took a long, long time to get it out again. So it's definitely a worthwhile meeting to have. Yeah, that good point. Now that's part of the OCPS design guidelines, and still now it's in the pipe flushing spec. Sufficient velocity of water in the pipe is extremely important. And in some cases, they wanted to just flush through the piping using street pressure in one end and just blow it out the other end. Well, you really have to maintain. Most piping systems are sized for 4 feet per second, give or take. So we want them to flush at 5 feet per second. In other words, we want to flush at a fast enough velocity that the water is going through fast enough to flush out anything that might be in there, instead of having it sit in the bottom of the pipe and then be picked up when the equipment goes into operation at its normal velocity. So sometimes that requires them to bring in a pump that's capable of generating those those water velocities in the piping.
I'll make a quick comment here. I was at a conference, I think it was about 2 years ago after this happened. Okay, loud enough. And I was actually in a discussion with another engineer. He was out of the Northeast United States. And we got in, amazingly, we got into a discussion about pipe flushing and about all the problems. And he says, I've never seen anybody, you know, really do it right. I've never seen a good spec on it. Well, we had just developed a spec, like Jonathan talks about, it's about 1 page long or whatever, very detailed, very rigorous. And I happened to have it on my computer and I shared it with him. And he came back to me like the next day at the conference. He said, this is the best pipe flushing spec I've ever seen, the most rigorous and the most diligent, you know. So, and that's part of your standard now, right, Tom?
Yes, it is.
It's, so part of what came out of this, it's now their standard, it's in the specs, and the contractors must abide by that, okay?
Jonathan, was the mechanical contractor hiring a third-party chemical treatment company to do the flushing?
Not to do the flushing. The mechanicals do their own flushing,
So the mechanical,
and with the treatment, water treatment.
okay, but they were issuing a report after they were done before startup.
Yes.
Yes, they were.
It's witnessed by Hanson and somebody from OCPS. It's usually me out there.
Sure.
You have in your procedure, once the system's been flushed, do you have them take out the startup strainers from your strainers and hang them there so you all know that they're taking them out? Because that's what we see consistently. You go and you look at the bolts on the strainers and they never, you know, the paint's still on them. And inside them is still the startup strainer, and I'm talking 10 years later. And that's another problem, because I saw your pipe, or that strainer plugged up like that. A lot of them think, well, we flushed it. No, you gotta take out the startup strainers.
Yeah, that is good point. That is part of the specifications, and that's something that a shortcut that gets taken sometimes that shouldn't be. They should be cleaning out the buckets, regularly throughout the cleaning process. I once went to one of our projects that had no problems. They would flush the system very thoroughly. They were changing out the strainer buckets like every day. They were going and dumping the debris out of them. He also brought in a side stream filter to better filter out the system. And we're talking about a high school with 8 buildings. And I said, well, that's not required by spec. Why did you bring it? And he looked at me and smiled and says, because I want to sleep well at night. I don't want to get called back on this. So there's a smart man doing a little extra now to avoid the headaches later. That's just smart business.
We're running a little over. You had a question.
Has the system given any consideration to hiring a TAB firm directly as a professional service?
No, they have not. It's been discussed, but they have not made that decision.
Oh, his question was, has the owner considered going directly to the tab contractor instead of having to go through the mechanical? And the answer was, they have not. They discussed it and they chose not to do that.
They used to do it, and they eliminated it about 10 years ago.
Voice of experience, because that was the man that was doing it.
The person that was managing it was not, in my opinion, was not part of OCPS. They were the program manager for OCPS.
The good thing that they do, that one thing that OCPS does insist on is that the tab contractor cannot work under the mechanical contractor. The tab contractor reports directly to the construction manager. So that gives them a little bit more freedom to tell it like it is without worrying about the mechanical contractor yelling at them for bringing stuff up. But that's the way it should be.
Yes, sir.
During your flushing process, in your specifications, you call for samples being taken throughout the
Yes.
process?
Yes, we actually do. And actually what they do this, and it's an informal process, but it actually works. They take a whole bunch of water bottles and they put dates and times on them. And as they flush the system, they take samples and they actually take a photograph at the end and you could see tells the whole story of how it goes from, muddy to clear. And when they get to clear, then that's when before they start the detergent flush and all the heavy crap is out of the system, heavy stuff is out of the system, they can...
Potty mouth.
And that last bottle Jonathan drinks.
I actually have a good slide that got taken out of the presentation with 6 bottles in a row showing the date and the time and everything, and got taken out.
So once the water comes clear out of the other end and they know they have all the heavy sediment out of the system, then they can reconnect the coils, the evaporator, the plate frame heat exchanger, because now they're just flushing soapy water through it. They're done with the heavy stuff is already out of the system. So the coils and the heat exchanger and the chiller evaporator barrel do benefit from a detergent flush, but they don't, they take steps that they get bypassed for the heavy, the initial flush of all the debris. Any other questions?
One more?
Tom, I heard that when we export the issues that are out there in post-construction at 6 months and then 11 months, are you holding a higher percentage on CMs to get the issues completed, so by 11th month?
Until recently,
So I know it's just new to what coming out of OCPS, but how's that going to work for you?
it's worked better. Until recently, CM ignored the CX alloy issues, and they were paid in full at construction completion. And so that's what, and we found that there are numerous issues outstanding, especially at the 6 month issue. There's sometimes there are 15, 20 issues still at 6 months. It's very frustrating because at that time, you're gonna have a hard time getting the contractors back. There's no money to bang you in the head, so it was kind of a problem. So just recently, now it's tied to money, so the CM is not gonna get paid until all the issues are resolved. So I'm anxious to see how it's gonna work. It should work perfect now.
Should hold it
Yeah.
fine now.
We've been trying to do that for years, but we just finally, just in the past few weeks, got that resolved.
Money talks, as they say.
One more, Greg?
On your, in your standard spec, since we have 5 different, say, mechanicals doing it, there's nothing that really states how much time the tab guy should support the commissioning agent, except for there's one designer that puts in there a minimum of 1 day. So,
Yeah, so somehow in one of the specs, there was one line, and I don't remember exactly which spec it was, it might have been in the tab, and it said that shall supply 40 hours of support. And the
That's
control,
the
and the
BAS.
controls guys
That changed.
got a hold of that, and they held to that, like, so I've got an 8-building campus, and they want to give me 40 hours of support. Didn't work. And so we actually have gone through with Tom specifically and rewritten to where it says either a minimum, which is you have to support. It's hard for us to tell the controls guy or a tab contractor, you need to give us X amount, because we don't really know. I mean, as we know, it's what you find when you get there. So that's why we rely on that contractor to historically look at what you've got, and we dump it on you to be the estimator for that, but we say we need you the whole time.
the problem is it's a bid situation when we do it to the CMs. So when it says a minimum of 1 day,
You could put it one
The
day.
word minimum.
Well,
you get 1 day.
that number can vary whether, depending on the number of outlets, the number of buildings. Our experience, and we've had the blessing of being able to do a lot of schools for OCPS in the last 4 or 5 years. For a single building, typically you can go through all the tab report at a 20% sampling rate in about 4 hours if you're really moving with the right support. So you have to multiply that number. Obviously, if you want to do that for an 8-building complex, it'd be it takes actually several days to go through it all. And but it is worth doing.
And we run into the same thing, because we say, hey, half a day to get this elementary school done. Great, half a day, we're good. Oh my God, we had 47 issues. You guys, this is all messed up. You've got to redo it. Then you've got to retest it again. And then we start going, well, we didn't bid 6 retests on this either. So it's, if everybody just does a perfect job the first time, it's smooth. I don't know why. Just do it that way, it's much easier.
If they did, they wouldn't need you.
Keep making little mistakes. Little mistakes are good.
And most guys, most guys, I'm happy to say, most of the tab technicians, they whip through it with a smile because they know they've done it, and they're just showing to you what they've done already, and it usually lines up within a few percent. It's only, a couple of 1 or 2 bad actors that we obviously want to call them out too, not because we're mean, but because we don't want